Welcome to MongoDB Local. We are so happy that you are here with us today. My name is Kaylee. Right now, we are going to have Jeff talk about converging AI and application data store. So please give it up for Jeff.
Hey folks, how's everybody doing? Great? Can you hear me? Awesome. All right, excellent. Folks, thank you so much for being here. It's an absolute privilege to be here in front of you all today, especially if you took time out of your schedules to be here with us today. Thank you very much. I'm Jeff Needum. I've got a few slides for us today. We're going to talk about insurance. We're going to talk about data architecture. We're going to talk about AI. We're going to talk about MongoDB. And we're going to start off this conversation with this question. What is a good technology investment? IT leaders and decision makers that I talk to across insurance, tell me a couple of things. They tell me that they need to consolidate, that they just simply have too much in their technology portfolios. SQL Server, Oracle, DB2, IBM IMS. They also want to future-proof. We want to reduce the amount of inventory, and we also want to invest in things that help us better prepare for the future. Well, what does that future look like for us? This is sort of one of the most important questions that I think that we can ask. There's a gentleman named Peter Schwartz who wrote a book called The Art of the Long View way back in 1991, and this book has sort of become a canon inside business management books. And what Peter wrote about, he wrote about scenario planning. If we don't know what the future holds in store for us, how do we make an investment that pans out well for us in the future? And what Peter did is he asked companies to imagine themselves in different scenarios. Picture 3 different scenarios that are plausible, could play themselves out for our industry. And when we take a step back, take a look at what's common and make sure that you're investing in those things that are common across each scenario, and that'll better prepare you for the potential surprise of whatever scenario plays itself out. An example of this could be regulatory disruption. There could be a market that suddenly us as an insurer we need to pull out of or heavily invest in, and this change happens over maybe 6 months. Maybe there's market disruption. Maybe Ford partners with Allstate, and Allstate is one of your competitors, and suddenly your automotive book of business is in jeopardy overnight. Or maybe you hire a new CIO or CTO, and he or she says that, we're AWS now, but suddenly we need to pivot, and we need to be an all-in GCP. So what's a good technology investment? Well, what if I told you one of these scenarios will play itself out in our organization, but you won't know which one is going to play itself out? If we send all of our developers to GCP training and this scenario never plays itself out, maybe that's not a good technology investment, right? So Peter's advice was take a step back, look at each scenario, look at the variables, what are the conditions for success that surround each one of these scenarios, and then make sure that we're kind of investing in the common thread. And in my opinion, that common thread, especially now with all this talk about AI, is the data layer. Make the data easier to work with, and no matter which one of these scenarios that plays itself out, this will be a benefit to us, right? A smart investment for the future. Well, that scenario, one of these scenarios, is actually playing itself out right now across our industry. It's taking budgets, it's taking time, it's tech investments that are already happening right now inside of our organizations. This is a study that was done by one of our preferred research vendors, Solent. It's an independent research vendor, Solent. They did a survey at the end of last year, and they found that over 62% of the insurers are already investing in generative AI use cases. 33% have things that are in planning, 29% have things that are in development, and 19% have things that are actually in production right now. So one of these disruptive scenarios is actually playing itself out in our industry as we speak. These are some interesting statistics that came out of a Workday study. Workday study included about 2,300 participants at the end of last year, mostly C-level. No surprise, everyone says, yeah, I want AI in my industry. Of course, right? It's going to have benefit to my industry. Well, 4% of the respondents said that their data was fully accessible. And of those respondents, 59% said that their data is either somewhat or completely siloed. So back to the art of the long view, what's a smart investment right now? The data. Make the data easier to work with. We have a few things that we have to do inside of an insurance organization, though. We've got to run the enterprise. We've got to keep the lights on. We've got to keep enterprise systems running. This is probably the thing that takes up most of our time, our money, and our energy, is to keep enterprise systems running. And now we have this new thing that's kind of in the shadows or in planning or in development, right? Generative AI. I have to innovate with AI. Maybe the board of directors is expecting us to make some sort of investment here and make some sort of impact on the business. These two things, in my opinion, are actually opposed of one another right now. Keeping the lights on, running enterprise systems, and investing in AI can be a dual investment for a lot of us. And at the same time, I'm expected to optimize IT spend. Running the enterprise, innovating with AI, and keeping the expenses down sort of seem to be diametrically opposed with one another. And so I want to pose the question today here, can we actually get these three factors to converge upon one another? Can I run the enterprise? Can I innovate with AI? And can I optimize spend? Can I do all those three things at once? And I go back to that first slide, what's a good technology investment? Insurance companies, financial service companies, boards of directors, IT decision makers, C-level. We want to consolidate the inventory of systems that we have. We want to future-proof, and we want to optimize spend. So the common thread here in the art of the long view is make that data easier to work with. You heard Dave talk about the three layers of AI, and it's a really good conversational framework in a very complicated space right now. We've got so many vendors, so much tooling, concepts that are in the mix here. And so the three layers are a good way to kind of separate things that are architecturally significant. We've got the bottom layer of the models, obviously the AI models themselves. The second layer being the data and the tooling to connect to those models, and the top layer being those business applications. The bottom layer, we've got a lot of vendors, and you heard Dave mention and Sahir mention, I think we've got the most open architecture to be able to work with any AI, any cloud vendor. But it's this middle layer that I really want to zero in on today, which is the data and the data architecture implications here. Most of the world that we live in insurance, we've got a lot of systems, we've got a lot of databases, but there is a tremendous amount of untapped, unstructured data waiting to be harvested, waiting to be made more easy to work with by business users, by developers, by AI, and I want to pay particular focus on the rest of today's presentation in this space. The top layer are the business applications themselves. This, again, is another set of research from our partner, Celent. The top use cases in insurance right now, servicing and operations being the biggest one, whether it's customer servicing, employee servicing, billing. The second most popular is underwriting and rating, followed by customer onboarding and marketing, and then followed by code development. The top three are particularly interesting because we're going to talk about the power of unstructured data in the rest of this presentation, and that's why I think these top three are so interesting. So let's talk about that middle layer a little bit. Let's talk about the data architecture implications in the middle layer. Again, what's a good technology investment? If I need to consolidate and I need to future-proof, the reality on the ground inside of an insurance organization is that we don't have one system that administers customers. We don't have one system that administers policies. We probably have 50 systems that administer policies, and 20 systems that administer customers, maybe a dozen systems that administer claim. So the first challenge right here is to consolidate the inventory. And what that means to me, and I think what that means to the industry, is that we're going to have to fold lots of legacy databases into one that can rule them all, right? So I want to build a single view, and I want to build that single view just for my application developers to consolidate the inventory and to have that domain of information in less places. So I make it easier to write business applications. I don't have to pay licensing for SQL Server, for Oracle, for DB2, for Postgres, just to administer policies. And this kind of ideal future state. So this is the world of future-proofing and consolidation for just basic applications. So the name of this presentation is the Converged AI and Application Data Store, right? So we've just covered now the application space. This is what application modernization looks like. Now, I don't think you can do this with relational. The notion of taking 50 policy issuance systems and 50 unique data models and putting them into one consolidated spot that can rule them all, I don't think you can do it with relational. In fact, I know that you can't do it with relational. If relational was going to be the answer, it would have been the consolidated data store 20 years ago. And so now this kind of brings us to, well, we actually do have single views in our organizations. They're called data warehouses, and they're called data lakes. We've actually been building single views of customer, single views of policy, single views of claim for a very, very long time. But we do it with historical data, and we do it in analytics platforms. And sometimes it's a day old, sometimes it's 2 days old. And so I want to come back to the middle here. There's a sea change that's happening now thanks to generative AI. So now let's shift from application data store to AI data store. If I am a claim handler, and I have a single view of claim, I've modernized my legacy inventory, I've consolidated, I've built a single view of claim. A claim handler might want the last 3 months of history to determine, what's the average turnaround time for the body shops? How can I communicate to the customer how long they should expect to wait? Well, if I shift personas now, and I say now that I've gone through all that data engineering and consolidation work and I've built a single view of claim, I want more personas and more business applications to be able to now leverage that data object, right? Consolidate, future-proof, what's a good technology investment? I want to build that data object once and have many personas interact with it. So if I am a underwriter, I might want 3 years of history on that data object. Now, 3 years of history might be in my data warehouse and my data lake. And what I'm suggesting here today is not that we replace our data lakes or our data warehouses with MongoDB. We leave them in place. You definitely want a data lake, you definitely want a data warehouse, and you definitely want to harvest out summarization insights from all that data. But the question is, will I put my runtime business applications against my data lake and my data warehouse? Will I put APIs, business 24/7 business APIs against my data lake and my data warehouse? Probably not, right? Databricks and data warehousing is a wonderful platform to be able to take advantage of a massive amount of data and harvest out insights quickly. But there's a cost to that insight, right? So I want data scientists to be doing that work, but when they harvest that insight out, I want to put it in MongoDB because that's going to make it operationally performant and ready and cost effective for things like business applications, for things like enterprise search. I want to harvest the insight out of the data lake and I want to put it inside a platform that's secure and performant and can scale for this, the scale that's necessary for business applications. So this is where I'm saying that single view, it might be operational data, it might be historical data. If I'm AI, I might want a blend of operational data depending upon the persona, the person that's coming to me and asking questions. And ideally, I want that in one place. If we instead have that data in 50 different systems and a data lake and a data warehouse, well, that's a really expensive round trip and a very complicated one if I want to ask a simple question of, show me the last 3 years of customer and claim history, right? So I might want that summary in to be operationally efficient and ready for applications to consume. But this is only half of the AI story, right? Now the AI in the room is really the unstructured data. If you've looked me up on the internet, on LinkedIn, if you've seen any of my LinkedIn posts, I've made a couple comments. I think insurance is going to be at the forefront of taking advantage of unstructured data, taking advantage of vector encoding and vector search. because of the sheer amount of unstructured data that exists in business insurance application workflows. Claim notes, claim damage photos, underwriting guidelines. If we look into any organization and we pick a domain and we look at the unstructured data and we look at how that unstructured data is being interacted with by the business workers, that's where the advantage is now for vector search and AI componentry like large language models, to be this ultimate data wrangler that can go out and fetch and retrieve and summarize information so much more quickly than as if a business user had to open that image, had to read through those notes him or herself. So it's the unstructured data, but the key here will be, can I blend that unstructured data now with the operational real-time runtime data, with the historical insights? Can I access all three types of information in a single platform? Consolidation, future-proof, that's really what it means to run the enterprise, to innovate with AI, and to optimize spend. So to kind of bring all this home and bring all this together into a real-life example, if you look at claim processing, for example, claim processing has a tremendous amount of unstructured data. Imagine a claim adjuster or a claimant, him or herself, taking a photo of the damage, whether it's a car or a building, and uploading that to a business application. How does someone inside the insurance company appraise the damage, right? They've actually got to physically look at that information, physically look at that photo and determine there was roof damage, there was window damage, there was a tree fell on the side of the house. So you have claim images, you have maybe videos. Some of the organizations that we work with, before they insure a property, will send drones up in the air to survey the property and analyze and scan for potential threat vectors, risk vectors, risk items, and try to appraise based upon those risks. So how do I process all that information very quickly? At the tail end of all that claim administration, claim adjudication, there's claim handling guidelines. Okay, so now that there's roof damage in the photo, how do I handle roof damage appropriately? I have to look up the guidelines myself as the claim adjuster. I have to read through the guidelines. I have to find the section in the PDF that's pertinent to this claim. All of that time, myself reading through the unstructured data, is where vector embedding and vector search is going to be now a kind of thing that speeds things up for us. It's not going to be the decision maker, right? But it's going to speed the ability to be able to consume and interact with that unstructured data now, which is something that we've really never had before. So if I look at a retrieval augmented generation workflow, kind of the basic steps here. Step one, I want to ask a question. And I want to ask a question maybe as voice or as text in a chat prompt. And I'm going to take that and I'm going to turn my question in my chat prompt into embedding, right? I'm going to turn it into a series of vectors. I'm going to then search my database for similar vectors against some corpus of information. When I get a set of results, I want to take that set of results and I want to now further dive into that. And this is where the operational data and the unstructured vector data kind of come together. Because now that I've got a hit on unstructured data, I probably want to drill down and filter into any existing operational metadata that I've already got. So if I have 50 claim systems and I've kind of harvested all that data out and put it into one single view, it's going to be a lot easier for a large language model to now interact with the corpus of data. And if that corpus contains unstructured and operational, there's a lot of questions that I'm going to be able to ask of that data set through large language models. So let's look at what this actually looks like in practice with a real-life example here. I'm going to give folks a QR code that you can actually download this for yourself at the end of this, but I want to kind of step through. So, okay, so I've got a claim event. I've got a really large rainstorm that came through a region of the country, and there were a number of automobile accidents that occurred as a result. And each one of those automobile accidents, somebody took a photo as the claimant, uploaded it. And what I want to do as the claim adjuster now is say, now that I've got a real-time claim coming in, how can I use vector embedding to take advantage of structured data more quickly? Well, I'm probably going to turn that into vectors. So I'll take the claim damage photo, I'll turn it into vectors, and then I'm going to search against my existing historical data set. And maybe I want to see, okay, this new claim damage photo, show me all the claims in my history that are similar. So I get a result set back, and now I want to ask the question of, I really want to filter down, just because there's broken windshields and the side of the door is crushed in, I want to know which ones were related to severe weather accidents. So now I'm talking about unstructured data that's gotten me a result set, but now I'm filtering down and kind of diving into, well, if that claim in history, only show me the claims in history that were related to severe damage. This is unstructured data and operational data, and this is the power of that single view inside your organization, not 50 systems that administer claims. One single view where all this information can be interacted with easily. Let me play this video. So I've got a damage photo. I upload this photo. Got some similar claims now that come back as a result. Let me go to the next slide so we can kind of just stay on that end result. So what you just saw there, I've taken a real-time damage photo, unstructured data, I've vector embedded it, I've turned the image itself into a series of mathematical numbers, vectors. I've bumped up against my claim history and asked, show me similar claims, show me claims that have damage photos that have similar characteristics. And on the bottom, on the left there, you see I've got the customer ID, claim date, I've got the status, but over on the right-hand side, which is even more impressive, I think, I've got all the operational metadata for those related claims. And so this is a great example of, on similar claims, I've got the damage photos that got me the result set, the vector embedding that got me the result set, but now I'm further kind of diving in and showing the operational data to the business user. Now this part, what you just saw here, this is just vector search, right? So for this claim damage photo, show me similar damages in my claim history and show me the results. This is just vector search, no AI, no large language models. So now how would I use a large language model, and how would I take advantage of retrieval augmented generation now to kind of further enhance this experience for the claim adjuster? Well, I'd probably let them ask questions of the data set to further filter in and really drive the result set that they want. So you see on the top left here, ask Leafy a question. So show me claims, show me adverse weather related claims, and what is the average loss amount? So now of a larger result set that I got with vector search, let me go to this so you can take photos of that larger result set, language model is now helping me further filter through the operational data. I found related claims, but only filter in where the adverse, they were related to adverse weather. And now ask the large language model to kind of summarize what's the average dollar amount. I'm not making a decision here, right? Maybe the math is approximate, not exact, but now as a claim handler, what I can do is I can have a basic level of understanding. Well, sir or ma'am, you're probably looking at like $2,000 to $3,000 worth of damage here. We'll know more when the adjuster completes the work, but right away, I didn't have to look at the image as the claim adjuster. I didn't have to go through history of images to find related claims. And as a developer, I didn't have to write a business API that asked the question of the data set, summarize summarize or average the loss amounts. I asked a large language model to do this for me without writing an API, and this is a really huge leap right now. So, as you saw, Dave and Sahir, again, back to these 3 layers of AI. The bottom layer being the models, the top layer being the applications themselves, the middle layer being your data. I think MongoDB has a distinct architectural advantage because, again, we're going to go back to what's a good technology investment. If my job as a data architect or an enterprise architect in these organizations is to help the business consolidate, is to help build and make more future-proof investments, I want a platform that simplifies and makes it easier to work with data. And I want a platform that can then take that simplified view of the data and make it open to whatever AI models are in the market right now and whatever AI models are in the market 6 months from now, 18 months from now, 36 months from now. So again, preparing ourselves for this sort of disruptive future where we don't know what the future holds in store, we take a step back and we do what Peter Schwartz told us to do. Use scenario planning, take a step back, and look at the common thread across all the potential plausible scenarios. And folks, I think that's MongoDB. I think it's make the data easier to work with. And when it comes time to consolidate that data, again, I don't think relational can do that. I think you really need something like the document model. So this is the first part of our demo. You can download that. There's actually a GitHub repository where you can check this out. There's a QR code there. This is the second part. So the first part was vector, and now the second part is the RAG component. Again, you can download this. These were both built by Luca Napoli, one of our senior consultants in the industry team. I like to affectionately call him my chief of staff. I'm sure he'll appreciate that when he sees the video. Folks, if you can, through the application, fill out the survey. So we talked about a few things, right? What's a good technology investment? How do we consolidate the inventory? How do we make that more future-proof? What are the data challenges? How do we start to prepare our organizations for artificial intelligence more? How do we start to use and leverage unstructured data within context of operational data? And how do we bring large language models to all of that to better leverage unstructured data within business workflows? It's been a real privilege. Folks, thank you so much. I really appreciate your time. Thank you so much for coming. I hope I've stimulated some thought. I'll be around for questions, but again, folks, thank you so much for coming.